and you may not have. It is a big piece of probability, which is not a big piece of this course as it stands, but it is a piece of it. So let's suppose I took a binomial to the first power. Okay, well that's easy. X plus y to the first is just x plus y. Okay? All right, what if I squared it? What happens when I square that binomial? What is that?
X squared plus 2x.
X squared plus 2xy plus y squared? Because it's a FOIL, right? The exponent doesn't distribute, it's a FOIL. Well, what if I cubed it? Well, if I cubed it, what does that mean? Foiling that times this? Okay, so because I've done it a zillion times, I know what that equals. All right. What about x plus y to the fourth? Well, that would be either this times this or this thing times itself, right? All right. Now, I am done. I could keep going, but I don't want to because we don't have time. I do not have this memorized, and I am not smart enough to do all this in my head. There is a trick. So what I want you to think about right now is, what would you think x plus y to the fifth would be? And maybe not the whole thing, but maybe you can just see pieces of it. Can you see anything that's going on here? What do you see, Quinn?
What would I think the equation's gonna be?
Yeah.
X to the fifth
So he says it's going to start with x to the fifth.
plus 5x to the fourth y plus
This is where it gets a little funky. Can you tell me anything about this next term? Maybe you don't know what number it'll be, but can you tell me?
x to the third y to the second
Okay.
plus x to the second y to the third x to the first y to the fourth and then y to the fifth.
I think Quinn's on to something. Would you all agree with that much of it anyhow? And maybe there's one more number you could stick in. What do you think? Take a look at this. What do you think maybe this number will be right here? A 5? Probably. Because doesn't that match that and that match that? So I guess this would match this. Does that sort of make sense to you? So the real confusion, thank you dear, they get funny when you don't check everything. The real confusion is what's going on there in the middle, and that's really what this lesson is about. If we took out all of the letters and looked at just the numbers, we have a 1 and a 1, then we have a 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and then this bottom row that Quinn was helping to develop, that bottom row, we knew it started with 1 and then had 5, and we knew it ended with 5 and 1. That much we can just see from the development of this triangle. These numbers in the middle, like this 4 right here, came from adding the 2 above it. So 1 and 3 made 4, 3 and 3 made 6, 3 and 1 makes 4. So what's going to go here? 10 and 10. So this number would be a 10 and this number would be a 10. So if I, furthermore, Quinn observed this and so did all of you. The powers on the first term of the binomial, in this case x, the powers are starting with this number and going down by ones. And then the second term of the binomial, they're doing the same thing from the other end. Keep in mind, there's really a y here, but it's y to the 0, which is 1, so I don't see it. And there's really an x down here, but it's x to the 0, so I really don't see it. So having done that, now I want to do one of the problems on the paper, which is example 10. Please look at example 10. And we're going to expand x plus 2 to the 5th power. This triangle right here is called Pascal's triangle. And you could keep it going for as far as you wanted to take it. The numbers do get surprisingly big, and so I'm going to show you how to handle it on your calculator. For little numbers, it's just as easy to build the triangle. But I will show you how to do it on your calculator. This is called, like I said, Pascal's triangle. Blaise Pascal was one of the great mathematicians, like Rene Descartes, you know, all those really smart guys. This guy, though, was a little odd. He ran with a bad crowd of people. They were called gamers. They gambled a lot. And they came to him because they knew he was smart and said, figure out a way to help us beat the odds. So believe it or not, the origins of this triangle are with gaming, with basically a coin toss, that kind of binomial probability. We'll talk more about that another day, but right now, we're gonna expand x plus 2 to the 5th power. Now, since we're going to the 5th power, we're gonna use this row of the triangle, the 5th row of the triangle. If that were a 4, I would be using this row of the triangle. Does that make sense to you? So, here I go. So I've got a 1, 5, 10, 10, 5, 1. Every single one of those coefficients will have both parts of the binomial. So I'll have an x and a 2. That's what's in my binomial, not an x and a y like I had before, but an x and a 2. So each of these will have an x and a 2. And anybody who dares complain about the tediousness of writing all this out, what's your alternative? Foil it. Now we're going to put our exponents on. Remember what we observed, what Quinn observed? If this is going to the 5th power, then this exponent's going to be 5. And they're going to count down. And then the 2's are doing the same thing from the other end. Quick comment. Notice in each term, and these are individual terms, so I'll separate it with plus signs. In each term, the exponents add up to 5. They will, they need to. Okay, now we simplify. We're done, we just have to simplify. So all this, remember, anything to the 0 is 1, so this is just x to the 5th. Now be careful here, you have a 5 and a 2. So this one's going to be 10x to the 4th. Now be real careful here. You have a 10 and a 4. So it's going to be 40 x cubed. 80 x squared. 80 x and 32. You okay with that? Easy peasy. All right. So let's look at example 11. 2x minus 1 to the 4th. Which row of the triangle will I use to get my coefficients? 1, 4, 6, 4, 1. Beautiful. what are the two parts of your binomial this time, guys? 2x and -1. This is a multiplication, this is not a subtraction. You have a 2x times a -1. A 2x and a -1. These are being multiplied. It's not a subtraction, it's a multiplication, just like you had with your x's and 2's. What power do I start with here on my 2x? 4, 3, 2, 1, 0, 4, 3. And these are individual terms, so go ahead and separate them. Okay, everybody with me? Okay, we start simplifying now. What's this? 16, x to the 4th, beautiful. It's not 2x to the 4th. The whole 2x got to the 4th, so it's 16. All right, now be careful here. We have a 4, an 8, and a -1, all times each other. So -32x cubed. Then we have a 6, a 4, and a +1, 24x squared. And then a 4, a 2, and a -8x. And what's on the end? I know it's under the TV there. What have you got? -1 to the 4th is just gonna be +1. Yep, +1. Problem doesn't ask you to do the whole expansion. This is what we do when it says expand the binomial. Expand it, figure out what it all equals. In example 12, we have x plus 5 to the 6th, but we don't want the whole expansion. We only want the term in the expansion that has an x to the 4th. Does it make sense to you that there will be a number in this list that has x to the 4th? So you just gotta figure out what its coefficient is. So, you guys are smart people, and you'll develop your own methods. What I like to do is just kind of think about, okay, so the first term is gonna have, first of all, which row of the triangle am I looking at? 6. And that row is 1, 6, 15, is that right? And here, this would be x to the 6th. This would be x to the 5th. Would this be the term I'm looking for? Would that be the one with x to the 4th?
Hello, Mrs. Ward. Mrs. Ward, were you teaching pre-calculus?
We're doing a little Pascal's triangle here. Expanding some binomials.
That's my favorite.
I know.
Can I borrow one of your students real fast?
Xander,
Xander.
we hadn't
turn
had
him
it
in.
for a week, but go ahead and take it.
Xander, come here. Okay.
Okay.
Xander, why do you have an orange lanyard?
Now, here's the
Xander,
thing.
why don't you have university?
The answer isn't 15. Because there's more to this term, right? What else is there in this term? A 5? So it is going to be x to the 4th, but it's going to be 5 to the 2nd, because the exponents have to add up to 6. So this term is going to be 15 times 25, which I should know what that is. Is that 375? So the coefficient of the x to the 4th term is 375. Does that make sense to you? Anybody have a problem with that? All good? All right. What is the coefficient of the term containing x cubed? Okay. Containing x cubed when the expression x minus 3 to the 1/8 is expanded. Well, what do we need? We need to know the 8th row of the triangle. On the notes sheet, it goes down to the 7th. So can you build the 8th row? 1, 8, 28, 56, 70, 56, 28, 8, 1. The triangle is symmetric. I hope you noticed that. We'll talk about why that is in just a second, but there it is. Now, I want the term that's what? X cubed. Now, if there's an x cubed, then there's going to have to be a -3 to the 5th. Would everybody agree with that? And all I need to know is, what's the coefficient? Well, this would be x to the 8. 7, 6, 5, 4, I'm gonna say 56. What do you think about that? Just counting. So it says, what's the coefficient? It's going to be a big number. I got -13608. Did I do that right? Okay, now, if I were you, I might be thinking about, that's okay, the 8th row is easy to get, but what if we were doing an expansion to the 18th power? Well, could you build the triangle to the 18th row? Yeah, but it would be very, very big and time consuming, right? So, the numbers in Pascal's triangle are what we call the combination numbers. What that means is, in the 8th row, the 8th row of the triangle, this is 8C8, the C stands for combinations. This one's 8C7, 8C6, and so on. Now, what this means is, we have 8 things, and we're gonna take all 8. So in other words, there are 8 x's. I'm doing this one again. There's 8 x's, and I'm gonna take all 8. Here, there are 8 x's potentially, but I'm only taking 7 of them, and then 6 and 5 and so on. All right? So, if this were an 18, and I wanted to know, let's say, the 5th term of that, I know that the first term would be 18C18, and then 18C17, 16, 15, 14. So 18C14, and that means 14 x's. There are 18 potential x's, and I'm taking 14 of them in the 5th term. And then that would have to be 14. And then -3 to the 4th, because these have to add up to 18. Now, where does that number come from? Well, get your calculator out. Calculator out, let's figure out how to do this, because otherwise you're going to have to do it by hand. I have 18 rows and you do not want to do that. So start by typing in 18. Just type the number 18. Then go to math. Look where I'm pointing, you have a button that says math on it. Right? Press math. Click across the top till you get to probability. That's, for me, it's the last one. And look in that column. Do you see a button that says NCR? That's it. Now you already put in your N. You already put 18. So now go down and hit that button and then type in 14 and hit equals. So the number of 18th row, the fifth number in the 18th row is 3060. That would have an x to the 14th, and then it's still gotta be multiplied by 81. This is all multiplied. So you have negative 3 to the 4th. So take that times 81. 247,860 x to the 14th is the fifth term of that expansion. All right, let's go through that one more time. Let's try another one more time. Let's suppose you wanted the sixth term of 2x plus 3y to the 10th. Everybody in this room agrees that it's some number and then 2x to a power and 3y to a power, correct? I don't know what the 10th row of the triangle is. I could build it. We already got it to the 8th row. We could build it. We could also use our calculator. The very first number in the 10th row is 10c10. 10 x's taking all 10. The second term will be 10c9, and then 8, 7, 6, 5. So this is going to be 10c5. Now that means there are 10 x's, and I'm picking 5 of them, so this is going to be a 5. That's how many x's are in the problem. And if there's 5 x's, then there are also going to be 5 y's, because they have to, the exponents have to add up to 10. All right, what's 10c5? Press 10, math, prob, NCR, 5, what'd you get? 252? Everybody get 252? Now, what are you multiplying that by? You're multiplying that by 32x to the 5th and 243y to the 5th. So 252 times 32 times 243. Oh my goodness, 195,955.2. X to the 5th. Okay, we feeling okay about that? Okay, all right, then let's look at the next page. And we're gonna work on some slant asymptotes, review a little bit. So would you do number 1 as a division? You can do it synthetic or long, whichever you like best. Remember, not everything is synthetically divisible. This one is, so if you want to do synthetic, make sure you know how to do long, though. Whoa, is that what you got? Okay, so what does that mean? What's the answer? The answer is x squared plus 5x plus 10, and then what's that? That's my remainder, and this is a division problem, so I'm gonna go ahead and have to include the remainder. When do I not include the remainder? When I am finding the slant asymptote, right? That's not what I'm doing here, I'm doing a division problem. So I have my quotient and I have my remainder. Now, for number 2, we are finding the slant asymptote. Okay, so here we go. What is the equation of the slant asymptote? Y equals x plus 5. Beautiful. So I'm not graphing this one, but if I were, I would have a line like this that would be an asymptote for the curve. Everybody still on the same page I am? Doing well? Alright, number 3. So I got some polynomial g, and x plus 2 goes into it evenly. X plus 4 goes into it evenly. So imagine that you did the division, and this came out to be a 0. What does that mean? It means there's no remainder. Okay. What does it mean if something divides in evenly? Doesn't that mean it's a factor? Like 5 goes into 10 evenly, so 5 is a factor of 10. When you have factors, what happens graphically? You have what? Zeros. You have zeros. So if that goes in evenly, then at -4, you have a 0. If it goes in evenly. All right, and then finally the last one says, let's not do the multiplication. Let's do B. B says, thank you. B says, is x squared plus 4 a factor of this? Guys, how can you tell real easily, how can you tell if something is a factor? What's going to happen when I divide? I get a remainder of 0. If something is a factor, then when you divide by it, you don't get any remainder. No, I said they put it in PowerSchool. Thank you, Bill. Thank you. So here we go. X squared plus 4, dividing it in here. What do I need? An x. So that'll give me x cubed and 4x. Alright, so I'll subtract. Okay, what do I need now? -6. Maybe somebody say it. Uh-oh. Is it a factor? Nope, why not? Leaves a remainder of 4. And if it's a factor, it would divide in evenly. Okay? Alright, I want to stop with that and look at a couple of homework problems, because as I've been grading homework, we got some issues. So let's look on the right page. Okay, so it's the 1-9-110 homework. And it's, if you still have your paper, great. If not, that's fine. Don't worry about it. I want to talk about this. So, this is problem 3A. So we need to make sure that we understand what is happening to the picture at these places. Okay? Now, what is this telling you? These are limits as x approaches 1. There's a hole there. There's a hole there. There is a hole at the point 1 comma negative 4. There's a hole in the picture there. Because as we are approaching 1 from both sides, we're actually going somewhere. As opposed to this, what's happening here with these guys? As we're approaching 4, we are heading off into space. And in this particular case, did you note? We're heading on both sides, we're going down. That's a little unusual. We've done enough, we know usually we're going up on one side, down on the other side. Here we're going down on both sides. All right, so what does this mean so far about our equation? Well, if there's an asymptote at 4, don't I have to have this in my denominator? And if there's a hole at 1, don't I have to have this in my problem? Okay, everybody good so far? All right, so I want to think about this for a second. Those are going to cancel, and I'm going to be left with 1 over x minus 4. That would have an asymptote at 4. But I want you to notice something. If you put in 5, don't you get a positive number? If you put in 6, you get a smaller positive number. So it looks to me like this is not the behavior that I want. Would you agree with that? Now, somebody might suggest, well, just put a negative in. No, what a negative does is change the direction of the whole thing. So this one is going down. If I plot 3, I get a negative number. So I am down. This one is down on the left, up on the right. I don't want to switch that. I want them both to be down. So if I want them both to be down, one way to fix it is to square your asymptote. Because if you square anything, then isn't the sign always going to be the same? Always. And if I put a negative in there, a -1, would that make it down then? Would that always be negative? Would that always be negative? So that's good. That part's good. What's the part that I'm still missing though? If I plug in 1, I'm supposed to get -4. Well, what happens, this is my reduced equation that I have right now. I've got to move in the right direction, but if I plug in 1, I get -1/9. I need it to be -4. Any thoughts on that, what we might do? What would it take up here to make that turn out to be a 4? 36. Would that do it for me? If I put in 1, I get 9 on the bottom, and -36 over 9 is -4. Is that okay with everybody? Okay? All right, then let's look at the second one there and talk about what's happening there. So we have the limit as x approaches -2. So that tells me I'm going to have a hole. Alright, so let's start building this equation. Oh, by the way, I still have to have the x plus ones in these, in my final answer. Or x minus one plus one. To get that whole. Okay. Alright, so what's happening in this one? -2, 3 has a hole, which automatically means that whatever my equation is, it's going to have an x plus 2 on the top and bottom. Alright, what's going on here? Vertical asymptote at 2. So that means I have an x minus 2 in the bottom. And let's see, on the left it's going down. And on the right it's going up. So you've done enough of these, you might be imagining a horizontal asymptote running through there like that, that would create a situation like that. Okay, well, let's see what's wrong with it. Those would cancel, so what I have right now is just 1 over x minus 2. And what do you think? Which gut feeling that you have? So, if, right now, if I plug in -2, I don't get 3. So let's go ahead and plug in something. What do I have to have if I want to get 3? If I plug in -2, would that have to be a -12? Would that give me the hole that I'm looking for? Yes. Okay, take your calculator out and sketch this for me. That right there has an asymptote just like you want. It has a hole exactly where you want it. Is this what your picture looks like when you sketch that? What's wrong with it? It's going a different direction. It's going a different direction. So I want you to think about what I drew. Would you agree that this picture makes sense according to the given? Now there are other options. I mean, I have it crossing like right here. It could be crossing over here, but it has to at some point between here and here, it has to cross the x-axis. Would you agree with me? Which means what do I have to have in there? 0. Now, where you put it, it's up to you. It might be easier on me to put it at the origin. Would that be possible? Which means that there has to be an x on the top. Right? Okay, now let's plug in -2. Or actually, graph that and see if it goes in the right direction. If I put in 1, I get a positive. So let me change that. Try that one. See if that works now. Does that go in the right direction? Okay, so now I just need to check if my hole works. So if I put in -2, I get -24 over -4. Uh-oh, that doesn't work anymore. So I need to change my 12. What should my 12 be? 6? There it is. And again, you have to have all the other parts in there, so -6x up here. So when you're writing your own equations, guys, you really have to pay attention to what direction you are moving with those asymptotes.